Let's draw the Lewis structure of CO2, which is carbon dioxide, step by step. Follow these steps to perfectly draw the Lewis structure of CO2. First, draw a rough sketch of the structure. Then, show chemical bonds between atoms. Next, mark lone pairs on the atoms. Complete the octet of the central atom and other atoms as well. Finally, calculate formal charge and try to achieve a stable Lewis structure with the least formal charges. Before sketching out the rough diagram, two essential steps are required. First, calculate the total number of valence electrons and then determine the central atom. The total valence electrons in CO2 are determined by adding the valence electrons of individual atoms. Carbon, belonging to group 14, provides 4 valence electrons, while each oxygen, a group 16 element, contributes 6 valence electrons. With 1 carbon and 2 oxygen atoms in CO2, the total valence electrons calculation becomes 4 for carbon plus 6 for oxygen multiplied by 2, giving a total of 16 valence electrons for CO2. When deciding the central atom for CO2, position the element with the lower electronegativity at the center. Considering the electronegativity values of carbon, which is 2.55, and oxygen, which is 3.44, favor carbon due to its lower value. Therefore, for the rough sketch of CO2, position carbon at the center and place 2 oxygen atoms on either side. 2 electrons represent a single chemical bond. Therefore, place 2 electrons on the left side to indicate the chemical bond between carbon and the first oxygen. Similarly, place another 2 electrons on the right side to represent another chemical bond between carbon and the second oxygen. This way, out of the 16 total valence electrons, 4 are utilized, leaving 12 electrons unutilized. Lone pairs are electron pairs not used in chemical bonding. Remember, each pair comprises 2 electrons. With 12 electrons remaining, mark 6 electron pairs on the structure as lone pairs. It's important to note that carbon and oxygen, both period 2 elements, can't hold more than 8 electrons in their valence shell. Another key point to remember is to always start by marking lone pairs on outside atoms first, and then on the central atom. In CO2, each of the 2 outside oxygen atoms gets 3 lone pairs, while the central carbon atom won't receive any, as we only have 6 lone pairs to mark on the structure. You can see that the octet is complete on the outside oxygen atoms, but not on the central atom carbon. So let's now work on completing the octet for the central atom carbon. Again, recall that carbon is a period 2 element and can't hold more than 8 electrons in its valence shell. Carbon already possesses 4 valence electrons and requires 4 more to complete its octet. Therefore, we will convert 1 lone pair from each oxygen atom and transfer it to the carbon atom to form a chemical bond. Now it is evident that the central carbon atom, as well as the 2 outside oxygen atoms, all form an octet. Thus, the octet rule is satisfied, and we need to check the formal charge to determine the stability of the structure. This is the formula we can use to calculate formal charges for the CO2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Simply input the data and place the values in to obtain the formal charges for each specific atom. For carbon, valence electrons are 4, non-bonding electrons are 0, and bonding electrons are 8. So the formal charge will be equal to 4 minus 0 minus half times 8, which equals to 0. For each oxygen atom, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. The formal charges of both carbon and oxygen atoms are mentioned, and it is evident that the current structure is stable, as formal charges on each atom are zero. Therefore, this structure is the preferable stable Lewis structure of CO2. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there are two pairs of electrons on each side, draw two horizontal lines on each side, signifying that carbon is double bonded with two oxygen atoms. So that's the Lewis structure of CO2. If you found this helpful, give it a like, share it with your friends, and subscribe for more.